Hello, everyone, and welcome to another K2 webinar, where today we're going to go through something a little bit different with our flat roofs. So you're probably all aware, you've read the invite. We're going to be talking about gravel and green roofs. To go through some of the physical products, my name's Kyron, and I'm going to be doing that part. But join with me, I have another colleague, Vladimir.
Yeah,
What will you be doing today? How will you be presenting to our
exactly.
attendees?
So I will show you base assembly instructions, checklist, and Karen will present you our components.
Okay, super. So I might just give you a moment then to prepare. I know
Exactly.
you've been doing some for that. And before we jump into some of the components, just a few housekeeping things. You should have all seen a quiz or a survey that's just popped up. We really appreciate if you could fill that out because it helps us know who you are, which can help us then provide a little bit better information. Also, if you have any questions throughout today, we would love to hear them or read them. Please feel free to put them in the Q&A section. So down the bottom of your Zoom, somewhere down here, you should see a Q&A button. And if you put your question there, we will be able to answer it directly. Everyone will be able to see it. And it's just kind of a clear way to ensure that all of the information is there and accessible. While I'm presenting, Vladimir will be going through the questions, and while he's presenting, I'll be answering some of the questions there as well. If we feel a question is suitable for everyone, we might stop our presentation a little bit and go through those questions because they're useful for everybody. And we will also have a chance at the end if you have a question that you felt like you couldn't put into text, but you'd like to ask us verbally. If you put your hand up virtually at the end of the webinar, we'll be able to turn your microphone on and you can talk to one of us, and we'll be able to answer them directly. I think that's about it for the Q&A side of things, not the Q&A side of things, the housekeeping side of things. So let's get into it. We are talking about effectively our flat roof products today, and we're going to have a bit of assumed knowledge. So it'll be assumed that you know our dome systems, and we're going to be talking about how, or a few things that you can do on gravel roofs and green roofs that are different to the standard system. And to start off with that, we'll just probably have a very, very quick recap of our dome system. We have our Mat S, and we have our peaks and our SDs, and we put our ballast on top, right? And so this is suitable in most cases, but if there's some advantages you can get from doing it a little bit differently, or utilizing the existing material that's on the roof. And that's a topic we're going to touch on a couple of times today, using this existing material. So when you have gravel roofs or green roofs, you already have this excess weight on top of the building. It's not necessary that we need to then put on extra ballast if we can somehow use that additional weight. And so one of the systems we have goes through this and sort of using the weight, and the other one is a little bit different, where we instead of putting the ballast on top, we put the ballast sort of underneath and screw the rail on top of that. So this is our express system, so it's not sort of the best example, but just to kind of give you an idea. And probably to show actually that one, we'll just jump off with one of the products that we have. And I just miscalculated how heavy that one was. Here is one of the example that I was mentioning before, where instead of putting the ballast on top, we put the ballast underneath, right? And so there are some advantages to this on also a cost perspective. So to buy a stone, if you're buying them in bulk, it's actually going to be a little bit cheaper than buying the Mat S's that we have. So you might actually be able to have a more cost-effective system, considering that when you do a system like this and you put the ballast underneath, it's just replacing the ballast on top. So you would usually have to put it on top anyway and buy it with the mat underneath. But in some cases, you can just put it underneath the rail instead. So how does this differ from our usual system? As I said before, there's no mat, so that's going to be something that's a little bit different. And we're going to screw it into the rail. And let me just tip that, and you can see on both sides, so over here and or even over here, there's a little screw that's inside or screwing the concrete to the rail, or vice versa, actually, the rail to the concrete. And those screws, sorry, I thought I had one just here, are Monty screws. So these come from one of our suppliers. There's a concrete specific screw, was designed for screwing into concrete. We also use a very similar one for our ground mounted systems. So they're designed for really sort of high load situations and are very, very sturdy. But you can buy then a box of these or however many that's required that base says, and you screw them into the rail wherever the base report gives it to you. And so that's something that, as I said before, Vladimir will be going through today. All of what we're showing today will be in base, and you can do it in base, which makes it then really easy to know how much ballast you need and how much and how many components you need as well. So when can you use a situation like this? So if you have a concrete roof, you could theoretically just place it straight onto the concrete. You've got concrete blocks on concrete roofs. If you have sort of a membrane roof, you might have an issue with the contact layer and need some form of protection mat or a sort of a second layer of the membrane before you put the ballast down on top of that. But the ideal situation is for green roofs and then also gravel roofs, where you can nestle the concrete actually into the ballast. And so if you have 5-10 centimeters of ballast, maybe even more, you can sort of space it away or spread out the ballast a little bit, put this in, and then bring the ballast back around. And that the gravel that's around the stones adds to extra stability and support on it as well. So you end up with a system that's very secure, and you're not going to need more ballast. In some cases, you might actually need less ballast to secure your system onto the roof, right? So this is also possible with the green roofs as well. One of the points about the green roof is that if you are going to put PV on top of the green roof, you are taking the sunlight away from that plant life underneath. So it's not always going to be a one-for-one exchange, but if you are putting the dome system on the roof, there is a big chance that the plant life underneath the material will no longer be growing, right? Just kind of one or the other. If that's something that is of a concern, we do have another system, which is the green roof vento, which sort of lifts everything up a little bit higher. And there's a bit more space for light to come in, and it's a bit more plant friendly, we should say. But it's not going to be what we're covering today. And we've got a webinar on that, which I think is on YouTube anyway. So you can check that out if you're interested in that. So just before we move on to the next system that we have, one of the kind of key points, or one of the maybe advantages of it, you're probably going to need more ballast blocks that might be necessary for your system. So if you know a base project, you'll see a ring around the edge usually where you need higher ballast. And if you are then in the middle of your field or the middle of your roof, you'll need less ballast. In a case like this, you are placing one of these big stones underneath every SD and every peak. So you might end up getting sort of more ballast over the whole roof, but not so much high concentrated parts. There is always the case of, or the opportunity, I should say, of putting more ballast on top, but just as we would usually do. But this is something that we wouldn't see so often, or if so, it's just going to be around the edges of the module field. And I hope the example that we have backs me up on that on that explanation before. But you'll see it once it's in base. It's pretty straightforward that you'll see here we need a ballast stone, here we need a ballast stone, and for this module or this bit of rail, we need an extra 4 kilos, something like that. So it's pretty straightforward. And so this is the one option where we put the ballast underneath the rail, effectively taking away the speed porters and the porters and the MAT-S and just putting these screws in.
Karen, we have some good questions.
Yeah.
For example, about technical requirements to our concrete blocks.
With the concrete blocks,
yeah,
it's a good question.
Yeah, so I would say from
our
in? Side there are like no requirements about this concrete. It's only the weight, so you have to calculate it in the base and put the correct weight, and the maximum height of the stone is 25 centimeters, and not higher, because our system was tested until this height and no more.
Yeah, and so that is something that you'll see in base as well. If you put in you'll be asked for the height of this, because if you do raise up off the roof, there is going to be more space for wind, and the wind analysis will, the analysis is still valid, but the output will be different. But just one point on that, so you are going to have to screw with these screws that we have here, and if your concrete block is too thin, you have to screw into the concrete. And if it's a grade of concrete that is not going to withstand being screwed through and will crack, if it's totally penetrated, then that's something that's not going to be suitable anymore. So as long as the screw is in the concrete and the concrete block is still one, that's sort of still valid. But we don't have a technical requirement in the sense of larger concrete foundations that you might have to vibrate, or you might need so much Rio involved, or you might need a certain C20, C24 grade concrete. For this, it's more expected that it'll be like a paver stone, or something that you could repurpose in sort of a garden for paving if you needed to, but that's sort of up to you. Was there another question as well?
Yeah, but it's a long one.
Yeah. So it's a question about the Dome Zero and the ballast requirements. And it's a really good question, actually, because the ballast for the Dome Zero has very specific requirements, and that's a little bit different. So we'll go into that a little bit in a little bit different detail. So as Vladimir said before, we do have a requirement that this height here cannot be more than, I think it's 25 centimeters, 250 mil. And that's because of our wind tunnel analysis. And so when it's higher than that, the analysis that we do, the estimation and the simulation process that we do is no longer valid. Right? So we make that as a limitation to ensure that the calculation is correct, and then you have the correct ballast. In Dome Zero, it's a little bit different, because the limitation is you have only a little bit of space in here. And so if you were to try and place something down here, and this is maybe not the best example, but you can see, you get my point, your module is going to hit the ballast. And so the limitations are, they're both really valid, but they're in here for different reasons. Just on the Dome Zero as well. So this option is not plannable in base in the Dome Zero. If it's really specific project, we might be able to help you out with a sort of a combination, but you'd have to email us, and you can talk to one of the two of us. And then we have another question about the ballast stones. So we do have a limitation in the software where you put in like the maximum amount of ballast that's there, and this limitation is set based on sort of what we've seen in the past as being a maximum or likely situation. So if you have a stone that is pushing more than 14, 15 kilos, it's already going to be quite big. And so if you have a stone that's then getting to 30 or even higher than 30, it's going to be a really large stone that's not so practical to get up on the roof, and you're going to have a really high pressure point right on the roof. So we've just set it in as 30 degrees for the fact that it will deal with the most cases. The question here, we have over 40.5. Yeah, that's going to be a bit of an issue. We can probably recalculate it internally if you need to. But what you could also do manually is to set your stone to 1 kilo. And then whenever you have more than 40 stones or 40 kilos in this case, then you just put 1 stone in. And if you have more than 30, it's going to, I know it's not going to be exactly the same, but it's just a way you can work sort of around this. But for these sort of specific questions, I would recommend emailing our team that Vladimir and myself are part of, who go through these specific projects, and that's service at K2 Systems as a K2-systems.de. We'll just put that in the chat now. And questions like this go directly to a team of about 20, I think, who will look at the case, like specific bespoke solutions or special situations where the software doesn't provide you with the answers you need. Okay, so this is one option that we have, and then the other option is similar but different. We're going to go 2 hands this time after what happened last time. And it's going to use a small PE plate. So it looks a little bit like a trapezoidal sort of sheeting. These are just samples. They come in, I think, 600 by 800 blocks, and we've got one. No, I actually have one here. That's so. Could you change the camera over, please, Klaus, or just do that one? So this one's actually been cut. We have another one that's a little bit to the left, but this is sort of the full size bit. And then they just screw into the rail as we had before, using different screws. Let me just take these out so they don't fall. Using different screws, but the idea is much the same. Now, and so how this differs, though, from the other system is that this obviously doesn't weigh so much. And so we are going to have this ballast underneath the module, but it's utilizing different points. And so this is something that we do to reduce the amount of excess weight we want to place on the roof by putting PV on the building. And in situations where we have ballast, in situations where we have gravel or green roof, we have some material that's already on the roof, and this has a density, right? And so for gravel, you're probably looking at, what do we say, 900 kilograms per cubic meter, and for substrate. So for green roof material, we're looking about 900 kilograms per cubic meter, and then for gravel over 1,300. 1,800, 1,900 of like material that's just sitting on the roof. And so if you have 5 centimeters or 10 centimeters or 20 centimeters of material that's on top of this, we can then sort of recalculate and say, all right, well, the area of this is 600 by 400, and then the volume of it working up, then multiplied that by our density means that this mat is now the equivalent of 20 kilos or 15 kilos or maybe 40 kilos, depending on the density of the material that's sitting on top and the height of it. So for every mat, we get an equivalent ballast value, and then that goes back into the software and says, all right, well, base says that this module that's sitting here needs 20 kilos. I know that this mat is a representation of 20 kilos, and this is the representation of 20 kilos, then we don't need any extra ballast here. The existing roofing material is already weighing that down, and we're done. Yeah. So there will be some cases where that's kind of goes the other way, where the ballast does not reach it. But in situations like that, you can also put a bit of extra material either on the PE plates themselves, right, or on the rails, as we had done in the previous point, or if you have the speed porters, you can put them on top of that. So,
or you can also use additional PE plates.
And exactly, or as Vladimir just suggested, you can also put more PE plates on the roof. So as we said before, if this is representation of 20 kilos and this is a representation of 20 kilos, and we have enough space, so I mean here it's just a really small sample, but if we have enough space for another PE plate in the middle, then this whole section is represented by 60 kilos of ballast, and in most cases that's going to be plenty. So with this one though, you can imagine you have to it covers quite an area, and so if you are sort of doing it as a retrofit, it can be quite difficult. We'd recommend doing this one more, and also with the green roof sort of in general, as a pre-build or part of the roofing and building process. Have the idea that we want to put PV on it, and then you can utilize the sort of style because it just makes it a lot easier than trying to remove all of the material that's on the roof, trying to get it back on. That can be quite a process that is quite difficult. So all of what we've spoken about today is shown in the east-west system, so the D-dome and the S-dome. For the S-dome, there is also the possibility of putting in 15 degrees. All of the sort of special, well, not special, but the requirements and the input values for the system, the input values and the output values for the system as a physical point are all shown in the software. So with any of the systems that we have, if you can plan it in base, you can build it. If you can't plan it in base, then either you can't build it or you maybe talk to us and we might be able to find a solution for you for that. We just had a question on the material of the trapezoidal plating. I don't know the answer to that.
We have both. We have not recycled PE plates, and we also have recycled PE plates. I believe you can even select it in base, but I'm not sure about it.
Okay.
We will see later.
Yeah, we'll have a look. Vladimir will show us later what the differences are. We definitely have different sizes of them as well, and we can go through that. But in generally, it's a plastic, some form of heavy duty plastic, and again, it's sort of being repurposed. Its design purpose is not to be in PV, but we can utilize it because it does exactly what we need it to do in this situation. So actually, we might be able to find that out while you're doing your part. I can have a look in that. All right, well then I think I will pass over to you, Vlado, unless you had any questions or anything else that you thought we could add.
No, I believe that's all. Maybe one important point that we cannot do it with express systems. This is only for classic and for our LS systems.
Yeah.
So you will be able to calculate it express on stones or on PE plates.
Yeah, it's a really good point. And just to go through that really quickly for those of you who don't know, the express system comes, forget this part, the express system comes pre-assembled with these mats underneath, and it makes absolutely, oh yeah, we have one over here. So this is the product. It comes assembled with the mats on the bottom and the parts pre-assembled. For you to then unassemble it and pull all these apart to then re-drill these parts in doesn't make so much sense. So it's only available in the classic system and the classic LS. But as we said before, once you're in base and it's not, you've got the express system and it's not working at the end, that's why. Cool, then I might pass over to you, Vladimir, unless there's another question that popped up, which hasn't.
So let me start with our usual web page. So first thing you will need to know, or you're usually trying to find, is our assembly instructions and data sheet. So the way is as usual. The first step is to switch to our product catalog. And here you have our DOM 6 systems. And as usual, if you select the downloads area, you have here assembly instructions, and you just have to find correct one. And this is somewhere here. This is our assembly instructions for domes on PE plates and stones. So you can see here everything how to install it as usual. The data sheet is also in this area. Here's, for example, for DDOM, the extent, you have here DDOM 16 Classic on PE plates and on concrete blocks, and also Classic LS on PE plates and Classic LS on concrete blocks. Maybe let us see regarding these PE plates. If we have it here, the recycled one. PE plates. Let us check. Yeah, exactly. This one, I believe, is the recycled one. Yeah, exactly. Yeah, recycling certificate. So exactly. And we will check if you can select already in base, because I'm not sure if it's already implemented in base. But you have this option. If it's not in base implemented, you can just, as usual, you can just change the bill of materials, putting manually this article number instead of this one or this one. So let us switch to the base. So I have prepared already a roof here. What I wanted to emphasize with this type of roof, it's very important part that you have to design flat roofs as an entire roof. For example, if you will draw this roof below, you have to draw it as a complete roof and mark this part as an obstacle. And this part, because it's higher than the rest of the roof, you can draw it as a single roof, and this part as well. So you can also draw it as a single part. So if you want to design D-Domain stones or S-Domain stones, here's, if you select gravel, base, let us change it and switch back. Base will always ask you to fill these fields. If these fields are not filled, you will not be able to proceed and calculate your system. So the damping height is usual for gravel is 15 or 60 millimeters is the usual one. This weight is also a usual weight, our experience value. If you have on your roof another damping height, or if you're not sure about this weight of the substrate, please contact your supplier, ask them what is the weight, to put here correct number, because it's very important, because this is your ballast value at the end. Exactly. So this is our roof. I will not go back to the loads and explain it again, because it's our subsequent seminar and everything was already explained to you last week. So let us select DDOM, and here our options. So as we said, you can plan express on stones. You can select classic or classic LS. Let us select classic. Let us draw it like a model field. Yeah, but we can see here is that we have some obstacles. Let us draw the obstacles as well. It's one rectangle obstacle. Yeah. And as you know, we have here such nice option in base, like automatical detection of the obstacles. Just select it and you will see the base is selecting obstacles for you, 5D obstacles. So you just have to click on it. And you have the obstacles here. Yeah. So this is our model field. Let's make it a bit bigger maybe. Like united, yeah, obstacle in the middle. So we proceed to results. And here it's our usual ballast, like you know, here's on speed porters. Here in the middle means that it's on porter long. And you can just select here, here's as always our question mark explaining what options you can select. Yeah. You can also click here and to receive more information. Yeah, for example, about base plates, or yeah, to see the video. Yeah. with naked guys. Exactly. And here, so you can select, for example, DDOM on concrete blocks. So it's our DDOM on stones. What is necessary here is to put the dimensions of your stones. As usual, here is question mark explaining what we have here to put. Let's make it a bit bigger, the stones. And important. And most important is to put the weight here of your stone. Let us make it with 15 kilos. And you can see here that you have underneath of each peak and of each SD, you have a stone because the rail must be on the same height. And where you see this rod, this red values, that means that one stone is not enough. So you have the choice to put speed port in this case and to put additional 12 kilo stone on it. In this case, more stones, or base calculates automatically these additional stones, because you will see here that you have more screws than green stones. That means that base calculates automatically for you these additional stones to be put under the rail and screwed in it. What else is important here? I believe that's all. So exactly, maybe. So let us do the same with green roof. So for green roof, our experience values for the height of the substrate. Let's change it.
Vladimir, this might be a good point to talk about the green substrate a little bit more, because you'll usually get 2 or maybe even 3 values for the green roof substrate. So you'll have like a dry temperature and a wet, sorry, a dry density and a wet density. For this green roof, when you're going to use the PE plates that we have here, the density of the material is paramount for the ballasting. Like, it is the ballast. So if you're unsure and they give the 2 values, always use the lower value. It's the more conservative value. And if you have a situation where it's dry for an extended period of time and the roof begins to dry out, you want to ensure that the ballast in the system is using the least value, or the least amount of ballast per centimeter up that's necessary. So this density, if there's a dry one and a wet one, use the dry one.
Like usual, just to be on the safe side, I just forgot to show something else. Now gravel roof on stones. Another important part here that you can, let's show ballast in kilograms, but you can also show it in stones. Yes. Or not? No. Okay. Then only in kilograms. Okay. Let us switch to the green roof. So the usual value is like 120 millimeters. It's like usual normal one, 140 millimeters, maybe 100 millimeters. And the weight of the substrate is much less as for the gravel. So our experience value is 900 kilos per cubic meter. And let us change it here. So let us select the PE plates. Interesting.
Oh, yeah.
I don't think so. 120 is usually enough.
Then go back to gravel.
Yeah, it's funny. It's not showing. Let's check it again. Okay, so let me maybe present it with gravel roof as well. And maybe then we will be able to switch to green roof. Yeah, exactly. These are our PE plates. So you will see that you don't need so many PE plates. in this case, so it's even less than our stones. And here you can see this very important value is equivalent on panel. So best calculates if you use this amount, this weight of substrate on each PE plate in this high. So you will get almost 30 kilos of weight on each PE plate. This replaces the ballast. And here you see this red spots. That means that here one PE plate is not enough. You have to put additionally 1.8 kilo, or as we said previously, you can use here an additional PE plate and don't put any additional weight on it. Also, base in this bill of material, base calculates automatically this additional PE plates you would need. You will hit here like all the green and additional 4 PE plates for the red spots. And in our report, you will also be able to see it. Let's open it. So I didn't create the full report, but a part of it. And here you will see number of additional PE plates required. And here's the value, so the weight, considered weight of each PE plate. So it means the value we just put on the PE plate. So the same we can do with other systems. Let us check with SDOM 615 classical S. That is our results. Let us put it on PE plates, for example. You see that you don't need any additional PE plates. So it's enough to put here one PE plate under each peak and under SD, under each SD. And if you put it on stones again, let's just put the weight of the stones. It's showing some errors. Let's try to refresh the page. Exactly. So you will see that you will need some additional weight, but it's also not so much, and you can just use an additional stone everywhere to compensate this amount you have to put additionally. So maybe that's our most important parts. Let's try again with green roof, because I really don't know why it doesn't want to show us. Yeah, no idea. So it's not working today. I don't know the reason. We will check it with our base team later. No, I cannot say why it's not working now. Like usually, if you try to show something in webinar, it's not working. Yeah.
Vladimir, maybe we could go through the report in a little bit more detail as well, because there are a few points that are a little bit different in the report that that provide I say a little bit more detail, I think, to what some of the other reports, and it looks a little bit different as well. So specifically to do with the ballasting values, because when you are going to add the stones specifically, you are still adding quite a bit of extra weight to the roof. And if you, depending on how you deal with that, you could be adding, like if it's a roof with a high load reserve, it could be something you really need to look into. So
yeah.
Just in the, I think a bit further down, oh, this is just standard ballasted though, yeah?
Yeah, this is our standard assembly plan where you have to put the weight.
Yeah. And maybe if we could compare that with the with that of a And so this is the table. Yeah. So this specific loads table is pretty. This has looked like this for the last, I don't know, number of years before we've had this other system involved where we're talking about the dead weight of the roof and the ballast on the roof. But when we're going to add more components in terms of the stones, it's going to look a little bit different. So maybe we could rerun this one with a stoned concrete block option. And then we're going to see it's going to look a little bit more different. There's going to be some more details that are in there. And yeah, on that specific loads part as well. So, and because sometimes these are the sort of questions, or these are the sort of roofs where we're looking to reduce the amount of ballast, a bit of understanding on this table is really important. I think here we see we've got like 3 or 4 more different different points. And then if we think back to base, this is the number of green blocks that we saw, or the green squares that we saw. And then this is going to be the number of additional ones as well. And so if you were to add 1 stone for every amount of extra ballast, so let me just jump back. So for every bit of extra ballast, then you would need, oh, sorry, now what am I doing? Lost my cursor as well. You'd need the values here. So it's just, be careful of then what you're going to look at in terms of if you're going to add the extra blocks or if you're going to add the extra kilos. So maybe you've bought 15 kilo stones as we've shown here. So wait. And then maybe we're going to buy like a 5 kilo stone as an extra stone. Or maybe we're going to use it as a 15 kilo stone. And depending on how you kind of achieve this extra ballast, it might have a bit of an impact on these values. So this table is pretty detailed. So if you are just joining for the first time, getting your head around what these colors mean and what some of the values in this table mean might be a bit much. But as we said at the beginning, we have some expectation of prior knowledge for these webinars.
Maybe one additional point to add, because you have here in this bill of material, you have only this multi-monty screws. So base doesn't expect you to combine speed porters and stones. So if you want to use speed porters for additional ballast, you will need to add them at this bill of material manually. So you know that you will need 2 speed porters for each stone. So just put it here manually. Yeah, and as usual, you can create here the bill of material, and one new option we are really proud about, that you can transfer this bill of material directly to the web shop if your supplier already connected with the base. Yeah, for example, this here is a list of all suppliers which are already connected, and if you are logged in the web shop of your supplier, you can just click on it, and this bill of material will be transferred automatically to the web shop of the supplier. Yeah. Do you want to add something else?
I think from what we had to show online and what we had to show with the physical products, that was about it for today. So we will then begin to wrap up. But if anyone did have any questions for the next couple of minutes, feel free to put them in the Q&A section, or put your hand up as well, so we can see the contact list or the attendee list, sorry, and it'll pop up if anyone wants to ask a question. I should probably just move that away so I can see what's going on. And then, as we said before, we will be able to turn your microphone on. You can ask us generally, but if not, that's okay as well. As I said, we'll begin to wrap up. So we'll quickly or shortly put on another small quiz. There's a bit more of a feedback quiz. Again, it just helps us have a bit of more understanding of how you perceived today, and if we can improve it in the future, we will look to do that. So we really appreciate your feedback on this one. If you could do that, we'd love it. Next week, we are doing a similar webinar. I will be on the base side of things. You joining next week? Okay, then we'll be joined by another colleague. That's good to hear. On tile roofs, you signed up for this webinar, so you probably know where to sign up for the next one, but I think we might even put the link in it anyway. So it'll be a bit more of an introduction to tile roofs if you don't have a if you're not something, it's not something you're using, or if you're just kind of looking for a bit of an intro on the topic, we recommend you doing on that one. And then in 2 weeks' time, I think, Klaus, we'll be doing it a bit more on a lot larger flat roofs. So last week was a bit of an intro to flat roofs. This week is flat roofs with gravel and green roof, and in this one in 2 weeks we'll be doing sort of larger projects and larger flat roofs. So there's a few tips and tricks that you can use in base to make your planning process a little bit easier. We'll be going through that as a recommendation, or to provide a bit of detail, because the team here go through these sort of large projects pretty regularly. We had one question on the concrete blocks. So if you have a concrete, I mentioned this before, if you're putting the concrete blocks, just the concrete blocks, and then you're putting it onto a concrete roof, you're not actually going to secure it in any way. So yes, we have the ballast, like these are designed specifically for gravel roofs and for green roofs, but in certain situations you can also put them on concrete roofs. This is something we see in certain places where cost of material is quite pressing. As I said before, it's actually a little bit cheaper to do it on the concrete, but this can be at the detriment of the roof itself or the building. So it's not the recommended solution, but it is something that is possible. You can just put the concrete blocks instead of the mats, and then it just sits on the roof as a brick would. So there's no need really for anything else on that. Pardon? We have a hand up as well. Okay, super. Tomasz. Hi, Tomasz. Would you like to ask a question? You should be on now. Tomasz, we can't hear you. So you might have to turn your microphone off mute if it is on mute. And if we don't hear from you in a few seconds, we'll assume you might have pressed the wrong button. Okay, if you do get it working, just let us know and we'll be able to answer or let you speak and answer, and you can ask your question then. So I think that we're pretty much done, I would say.
Yep.
Big thanks, Vladimir, for today. Pleasure working with you. Thanks for our attendees who took an hour out of your day. Hopefully we'll be able to provide you with some new information and useful information. You can take that moving forward. And of course, big thanks to Klaus, who makes it all the magic happen behind the scenes. Hope to see you again sometime in the future, maybe next week, maybe the week after. But if not, stay safe, stay happy, and goodbye.
Yeah. See you.